dear students, I am Nilanjana Sanyal, an online math tutor from India. I tutor students of the IB and the IGCSE boards from grades 9 to 12. This is my website www.nsonlinemathtutoring.com. You may visit my website to know about my tutoring services in more detail. Okay. We are solving word problems on the topic Arithmetic Series, and this is our fourth session on the same topic. We are solving word problems, and in this session we will be solving two more word problems. Okay. So the first question of this session is, an arithmetic sequence has first two terms as 4 and the common difference as 6. Okay. The sum of the terms of the sequence is 200 and find the number of terms. There are a certain number of terms in the arithmetic series which is having the first term as 4 and the common difference as 6, and we have to find the number of terms that are included within that arithmetic series to get the sum total as 200. Okay, so let's start with our answer. The first term means U1 is equal to 4 and the common difference, that is D, is equal to 6. Sum of the terms. We know the formula for the sum of the first n terms of any arithmetic series, that is Sn equal to n over 2, where n is the number of terms in the arithmetic series, and this is getting multiplied with 2u1, that is 2 times 4, plus n minus 1 times d, which is 6. Okay, so, and this is equal to 200. Okay. So, n over 2 and 2 times 4 is 8, 6 plus 6n, if I open the parenthesis, minus 6 is equal to 200. So, n over 2 and 8 minus 6 is equal to 2. 2 plus 6n is equal to 200. And I want to actually get rid of this denominator 2. So, I take out a common factor of 2 from the parenthesis. That is n over 2 times 2, and within the parenthesis we have 1 because 2 times 1 is 2 and 2 times 3 is 6. So, it is 1 plus 3n is equal to 200. Okay. And now we can cancel these two. So, we have, if I open the parenthesis, I get n times 1 is n plus n times 3n is 3n squared is equal to 200, which can be written as 3n squared plus n minus 200 is equal to 0. Okay, and this is a quadratic equation. We have to solve this quadratic equation in order to get the value of n, and n is the number of terms in the arithmetic series. So, n has to be a positive integer value. It cannot be a negative number. Okay, I would be opting for the quadratic formula to get the solution. So, n is equal to minus b, which is minus 1, plus minus under root 1 square is 1 minus 4 times a, which is 3, and multiplied with c. So, it is minus 200. Over 2a, that is 2 times 3. So, n is equal to negative 1 plus minus under root 1 and 4 times 3 is 12, 12 times 2 is 24, 2400. And this is the first minus sign and this is the second minus sign. When multiplied together will be giving us a positive product. So it is 1 plus 2400 over 6, which is equal to minus 1 plus minus under root 2401 over 6. Okay. So let us find out the value of under root 2401 first of all. So n is equal to minus 1 plus minus under root 2401. It is 49. So this is plus minus 49 over 6. Okay. Now if I take minus 49 minus 1 will be minus 50 over 6 will be giving us a negative value for n, which we cannot take. We have to reject that value. Therefore, we will be taking plus 49. Plus 49 minus 1 will be 48 over 6. So, this means n is equal to 48 over 6, which is equal to 8. Therefore, the number of terms present in the arithmetic series is equal to 8. Let us verify our answer. Let us check what is the value of S8. S8. Okay. I am taking this expression, n times 1 plus 3n. So, n in this case is equal to 8 and 1 plus 3 times 8. So, 3 times 8 is 24, 24 plus 1 is 25 and 8 times 25 is equal to 200. Okay. So, we have verified our answer and we are seeing there are indeed 8 terms. Therefore, we write our answer . This is the answer for our first question of this session. Let us move on to the next question. So the second question is, consider the arithmetic sequence 13, 21, 29, 37, dot. How many terms are needed for the sum of the sequence terms to exceed 1000? Now this is very similar to our previous question. What is the difference? The difference is in the previous question we had the equal to sign, equal to the sum of the terms was equal to 200, and in this case it is saying that it is the sum is exceeding 1000. So in our previous case we had an equation, whereas in this case we will be having an inequality. Okay, so that is the only difference. So let us start with our answer. This difference will be obviously causing some difference in the answer type. So, first term of this sequence is U1, which is equal to 13. What is the common difference? 21 minus 13 is equal to 8. Therefore, D is equal to 8. And we will be taking the same formula Sn, that is the sum total of the first n terms of any arithmetic series. This is equal to n over 2. We have to find the value of n, and it is 2 times U1. So, it is 2 times 13 plus n minus 1 times D, which should be greater than 1000. Okay. So, n over 2, it is 2 times 13 is 26 plus 8n minus 8 is greater than 1000. Okay. So n over 2, 26 minus 8 is 18 plus 8n is greater than 1000. And if we take out the common factor of 2, because I want to get rid of this denominator, it is n over 2 times 2. And within the bracket we are having 9 plus 4n is greater than 1000. And these two will be getting cancelled now. So it is 9n plus 4n square is greater than 1000, which can be written as 4n square plus 9n minus 1000 is greater than 0. Okay. So, is greater than 0 means this is an inequality. That is what I was saying, that in this case you will be having an inequality in place of an equation. We had an equation in the previous question. Okay. Since this is an inequality, what will be the graph, the corresponding graph of this quadratic expression? It will obviously be a parabola. And which parts can be taken? The values of n which will be giving the function value more than 0. That is, it will be above the x-axis. So, we may be taking this part or we may be taking this part. Both the parts give us positive values of the function. But for this part, the corresponding n values will be negative. And what is the meaning of n? N stands for the number of terms present in the arithmetic series, which cannot be negative. Therefore, we have to reject this part. We cannot take this part, we will be taking only this part. We have to take only this part because this part will be having n values, positive n values. Okay, we cannot take the negative n values. We will be having two values of n, one of them has to get rejected because it will be a negative number. Okay, so again we start with the quadratic formula. So that is n is equal to minus b, that is 9, minus 9 rather, plus minus under root 9 square, b square is 9 square which is 81, minus 4 times a is 4 times negative 1000, c is negative 1000. Okay. Over 2a. So, n is equal to negative 9 plus minus under root 81, and there is this minus sign and this minus sign, so we will be having a positive product, and 4 times 4 is 16 times 1000 is 16,000 over 8. Okay, so n is equal to negative 9 plus minus under root 16081 divided by 8. And obviously we cannot take the negative sign of the square root, we have to take the positive value of the square root because n should be a positive integer. Okay, so first of all let us get the square root of 16081. Square root 16081. It is 126.811 and I have to add negative 9 to it, so it is negative 9. Okay, so I am getting this to be 117. Answer is, I have taken answer and it just takes the previous value. So minus 9 is 117.811 and this should get divided by 8. So again, answer divided by 8 is giving us a value of 14.7264. So I can take it as 14.7. Okay. So this means n is equal to 14.7. But as I have said that n should be a positive integer. It cannot be a fraction or a decimal number having some decimal values, decimal digits. So what can be the value of n, the smallest value of n? Because we have seen this side. The total this side will be satisfying the criterion that the function expression is greater than 0. So we will be having more than one value of n. In our previous case, we had an equation, so we had a single value of n. But since this is an inequality, we will be having more than one value of n. We will be having the minimum limit in this case, the minimum value, and we can have any value of n starting with that minimum value. Okay. So the minimum value of n should obviously be equal to 15. N is equal to 15. Obviously, n equal to 16, if we have 16 terms in the arithmetic series, that will also be giving us a sum total of something which is more than 1000. But the minimum value of n should be equal to 15 in order to get the sum total more than 1000. Let us check. Let us check the values of S15 and S14. So what is S15? S15 is equal to, I am taking this value, n times 9 plus 4n. Okay. So n is 15. So 15 and 9 plus 4n. 9 plus 4 times 15. 4 times 15 is 60. 60 plus 9 is 69. So it is 15 times 69. 15 times 69. 1035. It is more than 1000. This is 1035, which is greater than 1000. Right. What about S14? S14 is equal to 14 and 9 plus 4 times 14. Okay. So what is 4 times 14 is equal to? It is 4 times 14 is 56. 56 plus 9 is 65. So it is 14 times 65, which is equal to 14 times 65 is equal to 910. 910, which is less than 1000. Okay. So you see, when we are including 15 terms where the first term is 13 and the common difference is 8, when we are taking the first 15 terms only, then we get a sum total more than 1000 for the first time. Obviously, if it is S16, if we take 16 terms, it will also be more than 1000. If it is S20, it will also be more than 1000. But the minimum number of terms that should be included is 50. Okay. Therefore, our answer will be number of terms is greater than or equal to 50. Okay. This is our answer. Okay. So students, let us stop over here for today. We will be meeting very soon in our next session. Thank you for watching this video till the end. Please give this video a like in case you found it useful. please subscribe to my YouTube channel and do not forget to press the bell icon. You will be getting notified as soon as I publish a new video. Okay? Please subscribe to my YouTube channel. I'll be getting motivated to make more new math videos so that you may get benefited by watching these videos. You may also ask me to make a video on any topic related to the IB analysis and approaches maths, or applications and interpretations, or ACE level maths, or IGCSE maths. If you want, you may request me to make a video session on any topic of your choice as well. Okay? I'll be trying to help you. Okay? So, bye for now.